Hi guys, so the last couple days we've been reviewing algebra. Today we're going to take a look at graphing lines. So that's our topic, and our goal is I can graph lines by making a table, using slope and y-intercept, and by finding the x and y intercepts. So 3 different ways that we can graph these lines. So we'll start with this example, graph y equals negative 2/3 x plus 5. And there's a note here. To make a table of values, you pick values for x and solve for y. If there is a fraction as the x coefficient, picking values of x that are multiples of the denominator will assure that you have whole number points. So here we've got a fraction, negative 2/3, in front of the x. The denominator is 3. So for my x values, I'm going to choose multiples of 3. So negative 6, negative 3, 0, 3, and 6 are all multiples of 3. And in this second column, I need to substitute the x values into the equation. So I've got negative 2/3, and then I replace the x with negative 6, and then plus 5. And when I calculate the value there, the reason that I'm choosing to multiply by, or I'm substituting in numbers that are multiples of the denominator is so that I can divide out. So watch what happens with the fraction here. 3 divides into negative 6, negative 2 times. So that helps get rid of the fraction. And then I just need to do negative 2 times negative 2 plus 5. And that gives me a y value of 9. So the point that I end up with is negative 6, 9. So I'll go ahead with the second one here. So the same setup. I'm going to substitute negative 3 in where x is. So this time, same thing. I can divide 3 goes into negative 3, negative 1 times. So negative 2 times negative 1 is 2, plus 5 is 7. So negative 3, 7 is the next point. And we love substituting in 0 because if I'm going to put 0 in for x, this whole term is going to equal 0 because it's going to be negative 2/3 times 0, which is just going to be 0. And then I add the 5 on the end. So the coordinate for that point is 0, 5. And when we're graphing lines, the table of values is going to be in a pattern. So you can see the pattern is 9, 7, 5. If we follow that pattern, we expect that we're going to get a 3 here and a 1 here. And the numbers on the x part are going to be 3 and 6. Now, I've already got the line on the page here. We'll double check that these points are on that line. So if I go to negative 6 and 9, that gives me a point right there. Negative 3, 7. There's that point right there. 0, 5. 3, 3, and 6, 1. Okay, so there's the line that represents that table and that equation. A couple things we want to mention on the graph here. When we graph a line, the point where it crosses the y-axis is called the y-intercept. And in this particular situation, it's crossing the y-intercept for the y-axis at 5. So the y-intercept for our line is 5. And you can see where that shows up in the equation. The other thing that I want to mention here is the pattern of the points. So it goes down 2 and over 3. So down 2 and over 3. And that pattern continues. Down 2, over 3, down 2, over 3, and so on. So that's actually the slope of that line. So remember we used the word, or the letter M to represent slope. A little bit of review from grade 9. In grade 9 we talked about how slope is rise over run. So for our line we can see that the rise, if we go left to right, is down 2 and then over 3. So the slope of our line is negative 2/3. And you can see where that shows up in the equation. So the slope and the y-intercept are definitely connected to the equation. So now we're actually going to do a question where we use the slope and the y-intercept and we avoid using the table altogether. This year especially, we're going to try and do these graphs without using the table at all. We know how to, we did it up above, but we're going to try and graph these without the table. So in order to do that, step 1, I need to identify the slope and the y-intercept. So remember that the number in front of the x is the slope, that's m, and the y-intercept is the number that's on the end, that's b. So the next step is to plot the y-intercept on the y-axis. So our y-intercept is 5. I'm going to go to 5 on the y-axis, and there is the y-intercept. So I plotted that. And when so step 3, we're going to use the slope to rise and run away from the y-intercept. So our slope is negative 2/3. I'll always write the negative with the top number. So if I go to the y-intercept, remember this top number represents my rise, the bottom number represents my run. So from this point, I'm going to rise negative 2, so I go down 2 and over 3, and that gives me a point. Down 2, over 3, and that gives me a point. Down 2 and over 3, that gives me a point. I can also work to the left of the y-intercept by doing the opposite. Go back 3 on the run and up 2 on the rise. Back 3 on the run, up 2 on the rise. And obviously that pattern continues throughout the line. So if I'm going to graph that line, I'll draw a line through those points. That line is a little bit too thick for me. Let's see if I can make that any thinner. Let's try that guy there. Yeah, I feel a little bit better with that. So just move that so that it's going through the center of those points. Great. So that line is y equals negative 2/3 x plus 5. And if we compare it to our line up above, we see that they're definitely the same line. So now let's take a look at how we can graph using intercepts. So it's important to remember what an intercept is. So the definition, the x-intercept is when a line or a curve crosses the x-axis. And so what you need to remember is this. So on my graph here, the x-intercept is this point right here. So that's the x-intercept. And the coordinates of that point are x. We don't know what value of x it is because we don't have a scale on there, but it's x, and the y value is 0. So that's why this star is important here. Any point on the x-axis has a y coordinate of 0. And when we're talking about the y-intercept is when a line or curve crosses the y-axis. So this point here is my y-intercept. And the coordinates of that point are 0, y. So just like the x-intercept, any point on the y-axis has an x-coordinate of 0. So it's 0 and then whatever the y value is. So we're going to do an example here where we find the intercepts of this equation of a line. So we've got our equation here. If we're going to find the intercepts, we'll start with the x-intercept here. So to find the x-intercept, sub in y equals 0, because like we said up above, any point on the x-axis has a y value of 0. So we're going to sub in y equals 0 and solve for x. So if I do that, I'm going to rewrite this. I've got 3x plus 4 times 0 minus 12 equals 0. The great news is that when we sub 0 in to these equations, it makes this whole part equal to 0. So really what we're doing is solving the equation 3x minus 12 equals 0. So we bring the 12 to the other side, we divide it by 3, and we get x equals 4. So that means then that the x-intercept is going to be 4 and 0. Because we got x was equal to 4 when we subbed 0 in for y. Now if we take a look at finding the y-intercept, find the y-intercept, we are going to sub in x equals 0 and solve for y. So same thing, we write down the equation. Now you know what I'm going to do this time is that I know that in this equation, when I sub 0 in here for x, that first part is just going to be 0. So what I'm going to be left with is that. Because the x term is going to disappear because we're multiplying by 0. And then I solve this equation. So 4y equals 12. And then when I divide by 4, I get y equals 3. So when I get y equals 3, that gives me the point 0, 3. So I've got my y-intercept, and I've got my x-intercept. Now just plot the intercepts on their appropriate axes and draw a line through the points. So if I draw a point at 0, 3 for the y-intercept, the line's going to go through that point there. And if I plot a point at 4, 0, that's the x-intercept, we have a line that's going to go through there. I'm going to steal, let's see, I'll put a line in here. I'll just try one of these guys. Alright, so I draw my line. Just make sure that looks pretty good, I think. It's going through the proper points. When we draw lines on a graph, we really should put arrowheads on the end to show that that line keeps on going. And if I was going to label this line, I can just write the equation that line came from. So that line is the line of 3x plus 4y minus 12 equals 0. All right, so now we are on to some examples. So we're going to graph these lines on the Cartesian plane. That's what we call this type of grid, it's the Cartesian plane, using an appropriate method. We're not going to use table of values for any of these. When we can easily pick out the slope of the y-intercept. So when it's in y equals mx plus b form, like it is in this question, we can identify what the slope is. And when we write the slope, we should write it as a fraction. So 3 is like 3 over 1. And the b value is the number that's on the end, so that's negative 4. So remember, when we know the slope of the y-intercept, we start with the y-intercept. So I'm going to put a point on the y-axis at negative 4. And then I count the slope from that point. So it's a rise of 3, 1, 2, 3, and a run of 1. So there's my second point there. And I can put my line through there. so it looks about right there. And remember that that pattern continues. So from the y-intercept to the second point here, I went up 3 over 1. So I can go up 1, 2, 3, and over 1. I can go up 1, 2, 3, and over 1. Same thing going down, down 3 and over to the left 1. So it should continue to follow that pattern. And so that's what that line looks like. So I'm going to write y equals 3x minus 4 to label that one, especially in this case because I'm going to put 3 lines on each graph. So for the next one, m is equal to -1/4. And the y-intercept is the number on the end, which is 2. So I'm going to go to 2 on the y-axis and put a point. I'm going to plot the y-intercept first always. And then from there, I have to go down 1 and run 4. So 1, 2, 3, 4. That's going to go through that point there. So I'll do my line through those points. Not even close. Let's try this. Try and these guys up a little better. That looks a little better. Okay, and I'll label that one so we're clear on which line is which. So we're going to do y equals -1/4 x plus 2. And the last one here is a little bit mixed up. Now you can rewrite it if you want. Y equals, if I move the -2x to the front and the +3 on the end, I can certainly write it like that. It's not necessary though, as long as you realize that the slope is the number that's in front of the x, and the y-intercept is the number that is a constant. It doesn't have a variable with it. So now I'm going, y-intercept is 3, and then from there I'm going down 2 and over 1. Down 2 and over 1. Down 2 and over 1. I need my line to go through those points. Okay, so I'll just extend that line. When we draw these lines, we really should extend them to fill the graph. And we'll talk more about why that's important later on. But just trust me on that for now. So I'll put my arrowheads on the end of these lines, and I have to label that last line. So the last line we had there is y equals 3 minus 2x. All right, we're down to the bottom ones here. These ones are not in y equals mx plus b form, so these are good candidates to find the intercepts. I'm going to suggest that when you're finding the intercepts, you make a little table like this. And really, we want to find what y is equal to when x is equal to 0. And we want to find the other intercept, which is what x is equal to when y is equal to 0. So if I sub 0 in for x, so in this case here, I'm going to end up with y equals 5, because the x is going to disappear, so that means that I get 5 here. So that's the point 0, 5. When I put 0 in for y, I end up with x equals 5. So in my table, I've got a 5 here, and that's the point 5, 0. So I'll plot those points, 0, 5, and 5, 0, and then I'll draw my line through those 2 points. Okay, I might need to fix that a little bit. Perfect. Okay, so that is the line x plus y equals 5. Next up, same thing. It's not in y equals mx plus b form. So I'm going to create this little intercept table. And remember, on the intercept table, I need to choose 0 for each one, and then figure out what I get. If x is equal to 0, my equation is going to look like this. So I need to solve that equation. So if I take the negative 12 to the other side, it becomes positive 12. And when I divide that by negative 4, I get negative 3. So that's the point 0, negative 3. And when I put 0 in for y in this equation, I get 2x minus 12 equals 0. So if I move the minus 12 to the other side, it becomes 12. And then when I divide by 2, I get 6. So these points are at 0, negative 3, and 6, 0. And then we'll draw our line through those. Just extend that line. And so that equation is the line 2x minus 4y minus 12 equals 0. Okay, last one. So for this one, we'll set up our table again for our intercepts. So when x is equal to 0, we get this equation here. We take the 14 to the other side, it becomes minus 14. And when we divide that by negative 7, we get 2. So 0, 2 is the y-intercept. And if we sub 0 in for y, we're going to get 2x plus 14 equals 0. And if we solve that, 14 to become negative 14 on the other side, divided by 2 is negative 7. So that's the point negative 7, 0. And then we plot those points. So 0, 2 is going to be here, and negative 7, 0, 1, 2, 3, 4, 5, 6, negative 7 is there. And we can draw our line through those 2 points. Okay, so we end up with that equation there is 2x minus 7y plus 14 equals 0. Okay, so that's the end of our video. We'll do some practice tomorrow in class. Thanks for watching.